Thank you, Donut Guitar. I was muted. Yeah, thank y'all. Yeah, I am unmuted now. Basically, I was just saying, make sure you check in at this link to get the points for your attendance here. Super important to check in. I know I say this every time, but it is really important to check in so that you can get what you deserve for being here. Yeah, no worries at all. I think my hearing is pretty bad too, but you just didn't hear me at all because I was not speaking. So I swear they usually put they have a mute icon, like a muted icon right next to your name, but because I have the check-in like right here, it's not there. Like, see, now it's there. But when I put the check-in link, it takes it away from me, so I can't see if I'm muted or not until the check-in link is gone. So thank you for letting me know. But I'm gonna get started in just a little bit. How's everyone doing? How's Global Hack Week been going? This is day 4 still, but it's about to be day 5 after Quinn does the Today in Global Hack Week day 5 stream. So we're almost there. We have 2 days left. So we have day 5 and day 6 left. So has everything been going for y'all? Any interesting streams? Anything you're looking forward to that's coming up? Anything at all? But if not, I'll take down the check-in link. It's in the chat if y'all need it, and we can just go ahead and get started. Ooh, I see a dinosaur. Nice. Not really sure what the linkage there is, but maybe there's a stream related to dinosaurs? I don't think so, but if there is, that sounds super cool. Maybe that's related to Type Racer? I don't know. I'm looking through the streams and nothing looks like a dinosaur. I don't know. Hello. The slides for yesterday and today. So you can watch the YouTube. Let me copy and paste that. This is like a technical track, but they're not really related to each other. So don't worry about it. You don't have to watch the other videos that I've done so far this Global Hack Week to be caught up for this one. But let me send the videos from my past 2 ones anyways. The slides really aren't anything. It's basically just me going through the different sections. The slides are completely useless. Okay, I'm not gonna say useless because I made them, but they are not useful. Okay, this is not working. But basically they just you won't get anything from them because they're just me transitioning between sections of my stream. So yeah, let me know if you need any help, but the videos should give you everything that you need. They've all got everything that you need there. Oh, I see the green color is MongoDB. Okay, I think the MongoDB stream already happened. Are they doing another one? Maybe you're saying you liked the MongoDB stream. Yeah, because the MongoDB stream is done. That happened on day 3, I think, with Rosendo. Hopefully, sounds like y'all enjoyed that. I'm going to join How Cybersecurity Works. Ooh, that's mine. Command Line 101 and the AWS workshop. Very cool, very cool. I think I'm also doing the AWS workshop. Let me double check. My calendar. I'm pretty sure I'm doing the AWS workshop too. Right? Yeah. So I'll be doing How Cybersecurity Works, and then Vincent is going to be doing the AWS workshop for us. But I'll be moderating, so you'll see me twice. Yep. Yeah. MongoDB. Nice. Okay, so we're going to go ahead and get started. Make sure y'all check in at that check-in link. But if you need anything, just put it in the chat. I'm constantly looking at the chat. And if you want to get prepared for this session, I'd open up VS Code and Google Colab. I have started becoming a very big proponent of Google Colab because it's super easy to use and it just runs everything natively. So I would open up both. But we're going to go ahead and get started. So If y'all haven't seen a stream of mine before, hello, I'm Darshini. I'm a coach at Major League Hacking, and a fun fact about me is that I have a blahage. I've been doing this a lot. Like I've been doing this in every stream because this is like the only blahage time I get with my blahage. It's just a gigantic blue shark. They're from IKEA, and they're an icon with Major League Hacking. My fun fact used to be something like, oh, like I moved 13 times, but I really like taking the shark out because then I just get to like hug the shark before I dive into a 2 hour technical stream. So that's my fun fact. If y'all have any cool fun facts about you, feel free to put it in the chat. We can talk about it. This is going to be a very chill stream. It is mainly like me talking and like technically teaching y'all, but if you want to discuss anything, feel free to put it in the chat. And that's why we live stream. Checked in using the link, but not reflecting on my MLH profile. You might have to wait a little bit. I think there's like a slight delay in between when you check in and when it shows up. The real problem is going to be when, let's say you check in and then tomorrow in your like automated registration email, if you don't like receive that you've been checked in, that's when you can open up a support ticket. But if that problem still exists, just go ahead and open up a support ticket, and somebody in the MLH Discord will help you. Yeah. So I'm going to go ahead and keep going. But yeah, that's me. Feel free to intro yourselves in the chat if you would like. So here's our agenda for today. We're going to be covering a lot, but it's not going to be like an overwhelming amount. It's going to be a lot of me talking to you, but we're also going to do a couple of really fun demos. So just brace yourselves. It's going to be a lot of me talking, and I'm going to try to make it interesting. I've like included some analogies that I think you'll find interesting. Like yesterday, I was doing like cooking, like chef cooking analogies. So I'm going to do something similar to that. So yeah, we're just going to go over this like a rough agenda. There's no like timestamps associated with it, but these are roughly the sections that I'm going to cover. And this is what I was talking about Victory Taunt Witch earlier. Like these slides are just me transitioning between different sections, not really me like presenting anything that would be useful to you like past this stream. So let's dive right in. So for like introduction and context of just like what we're going to be doing. So we're going to be talking about what the cloud actually is, how it works like behind the scenes of what you see, and also we're going to be doing some hands-on demos together. So you might have heard about cloud computing, maybe from like Google Cloud, AWS, or Azure, or maybe you've even seen like the Save to Cloud button on like Microsoft Word or like, yeah, Microsoft Word, Excel, things like that. So hopefully by the end of the stream, like you'll have a little bit more clarity about what that means and you'll be able to try that yourself. So by the way, since this is Beginners Week, this session is super duper beginner friendly. You don't need any cloud experience. Like you don't need to know Python, JavaScript, none of that. Like I will teach you everything that you need to know. You don't even need like a cloud account to follow along because everything that we're going to be doing is going to run locally on your machine. And it's going to be simulating what happens in Google Cloud. So typically when you're using cloud computing, you have like a service that you're using and you charge on your credit card for that. But we're just going to be simulating that on our on our local machines, because I don't want to cause any credit card charges. And it's a lot of work to do a free trial because you might forget to cancel it before it charges you. And I don't want to be the cause of that. So we're just going to be doing local simulations. I don't really know what that is. Let me know if that's something related to the stream or if there's some context to that. Hello, Aif here. Hello. So first we're going to be talking about like what the cloud is, why it's such a big deal, and like the building blocks of the cloud. And it's just going to be a lot of like theory about cloud computing, a couple of like real world examples of how we use cloud computing, and then some like demo practice that y'all can code along live with me so that you can like learn something and then be able to use that same concept within the same stream. So first, a little bit about like why cloud computing matters in the first place. You can like I use these examples a lot, but like YouTube, Instagram, Google Docs, Netflix, like Spotify, all of these apps you're probably using daily. Do you know any other browsers other than Google? I'm going to China. I don't know what browsers work in China. I'm not like well versed in international restrictions. Other browsers might be like Microsoft Edge, Safari, Firefox, Mozilla. Yeah, I those are a couple examples of other browsers. You might want to search up like before you go, like what browsers you can use and get that downloaded on your machine so that you have that ready to go though. But yeah, like I was saying, lots of apps that we use day to day, and none of these apps live like entirely on our like smartphones. I don't know why I said smartphones, like just phones, and our computers because they're powered by like gigantic servers and data centers that are all over the world. So like a bunch of different data centers in like Sydney, Australia, like Utah, like random places that can store these massive data servers. And the cloud makes it possible for us to take a small app, like a very small app, and scale it so that millions of users can use that app without the company buying like a bunch of computers upfront. It also means that you can store files, run programs, and like collaborate with your friends on any files without like sending gigantic email attachments because you know the pain of trying to send something through Google or through Gmail or any other email app and it's like oh Gmail doesn't accept this large of a attachment so we're going to attach it to the Google Drive link and then you have to like share access and it's just like so much work that's all so unnecessary. So basically on the business side the cloud saves companies money and it makes them more flexible and it helps them innovate faster. And like for us, it just helps us be more convenient and helps us access things quicker. So, a lot of different apps that are powered by the cloud. Almost everything that you use is probably powered by the cloud. So that's super cool. And something that like would be really like something I think is a common myth about clouds is like when you think about clouds, like even the emojis that I sent in like the Discord announcement, like they're like fluffy white clouds, but like the cloud is actually in someone else's computer in like building. So it's not like up above in like some mystical magical land. It's like in somebody else's computer in this like big building. So we're going to learn about how the request goes from your laptop all the way to the cloud server and then like all the way back. So we're about to get into it about the foundations of cloud computing. We're going to switch sections here. So before cloud computing, like before cloud computing became super popular, everything was local. So by local, I mean like everything was hosted locally. And if you wanted to run an application or store files or host a website, you would have to do that on your own physical computer that you have. Companies used to buy like gigantic racks, like thousands of servers, and they stored them in server rooms that were like air conditioned because you didn't want the server overheating. And if you needed more power, you had to buy more servers, which, you know, a server used to be so big back in the day that it would take like so much time for a new server to arrive. And like you can see how this process would be like super expensive, super like rigid and hard if you needed more power. And it's like how horrible of an experience it would have been if all of a sudden your computer just like failed on you at like 2 a.m. You can't just get a new server because they would take so long to ship and they were so expensive. So that's why this shift to the cloud was so nice because instead of owning all of that hardware, now basically using the cloud, you can rent computing power instead of renting servers over the internet. And you can just like scale your company up, so make it bigger, or scale it down, make it smaller in just like a matter of like seconds or minutes. And you only pay for what you use, just like electricity and water. So instead of having this system where like you buy servers and even if you don't use them, sucks for you, you still bought it. You only pay for what you use, and it's very like it's able to take very minuscule changes. So that's super nice. So like if you think about the times before Google Drive existed, you might have had to wait hours for like a file to download or transfer, but now Google Drive exists, so you can just get the file really quickly. Um, and if you're wondering, just like as a basis, what cloud computing is, it's basically just like having the ability to deliver computing resources whenever you want. And computing resources like servers, storage, databases, and you're delivering these computing resources over the internet with pricing that you can use as you go. So it's not just like standard pricing, it's based on your usage. You can kind of think about it like Netflix for computing. Like if y'all remember the like Redbox movies where you would like rent the movie, like you're physically taking that movie. But with Netflix, it's like you don't really own the movies. You're not taking any movies. You're just like renting them. You can access them anywhere, anytime. And it's really similar with cloud computing. Because it's like on demand, you can use it wherever, and like everybody puts their resources together to have this one service, and it's measured service, meaning that you only pay for what you use. So it's kind of similar to Netflix in that way. Like they're very similar kind of like subscription services. Like hopefully that analogy makes sense, but it's very, very similar. Um, and there's three main types of cloud services. You've probably actually used like most or all of them. You probably haven't realized it because, cloud services I feel like are pretty native and hard to understand. But the three main cloud services are IaaS, PaaS, and SaaS. So people say like IaaS, PaaS, SaaS. I don't know. So the three types are infrastructure as a service. And what that is you're renting actual infrastructure, which means servers, storage, and networking, and you're managing everything on top of that. So an example of this is like Google Compute Engine. So maybe you've used that before. The second type of cloud service is platform as a service. So you get to rent a platform as a service to build and run your apps on without having to manage that infrastructure. So maybe you don't want to manage all the servers and the storage and the networking. You just want to build your app on this platform. That's where you would use platform as a service. And then finally, you've got software as a service, which is where you would just use the software. You wouldn't have any servers, you wouldn't have any maintenance. You just use the software. So this is like Google Docs, Gmail, Google Drive. You can use all these services, but you don't need like a server. Like you don't need to build a platform. You just use it. So, going back to my food example, because I really like food, you can kind of think of infrastructure as a service. You are like cooking your own meals from raw ingredients. Like you go to the store, you buy like chicken, like raw chicken, you buy like vegetables, you buy like seasoning, and now you're going to cook a meal out of that. But with platform as a service, you would get a meal kit with the ingredients prepped. So basically, you get like a kit from the store. It has everything cooked, everything ready to go. You just have to make it. Like you have to mix it, heat it up, whatever. And then finally, you have software as a service where you're just ordering takeout. Like you're not making anything. You're just putting the order and the food comes to you. So in terms of like convenience, software as a service is definitely the most convenient, and then infrastructure as a service is definitely the least convenient. But you can also kind of think about it in a different way where you have the most amount of customization with infrastructure as a service because you can pick the actual infrastructure. But with software as a service, you can't do any of that. You're just running your own software. So different ways of thinking about it. There's advantages and disadvantages to both. But yeah, software as a service is definitely the least like platform heavy, knowledge heavy. So it's nice if you just want to use your software. And we're going to be talking about 4 main deployment models too. So there's like, I guess 4 different types of like cloud. I know maybe if y'all had like learned about this in school, like Cumulus, like Strumbulus, I don't know. There's types of clouds. I know Cumulus is one of them. There's also types of cloud services too. So first you've got public cloud, and that's where your services are delivered over the public internet and they're shared across a bunch of customers. Then you've got the private cloud, which is like for a single organization. And this is often used by like banks, governments, or companies that have really strict security. And then you've got hybrid cloud. So we had public, we had private, now we have hybrid. So hybrid is a mix of both public and private cloud. So the way you can think about that is maybe you have sensitive data within the private cloud, and then you use the public cloud for like pieces of work that you can try to scale up. Finally, you've got the multi-cloud, which is where you use more than one public cloud provider at the same time. So maybe you just want to use like different providers for different reasons, and that would be multi-cloud. So for this session, we're going to be looking at Google Cloud just because it's like easier to use. And Google Cloud is a public cloud, but the same concepts that we're going to be doing in this session and also like the general public cloud concepts apply to Amazon Web Services and Azure too. So if you've heard of those more often, whatever we're doing with Google Cloud can also be done with those services as well. Okay. So I'm curious what y'all think. What model do you think most companies use today? Do you think it's public, private, hybrid, or multi-cloud? If you don't want to type out the whole word, let's do numbers. So we've got 1 for public, 2 for private, 3 for hybrid, and 4 for multi-cloud. So feel free to just type the word or put the number if you're feeling a little bit tired and you just want to get it out with. So I'll wait a little bit and let's see what model y'all think is what most companies use today. Okay, I'm seeing a couple of answers come in. Okay, so I'm seeing Donut Guitar say hybrid, Pizzo Fraud saying multi-cloud, Abiolac saying multi-cloud. Ooh, just got to know about multi-cloud. Good, we're learning new things. I'm glad that's the purpose of this whole stream. Cato Todan says public. Okay, I'm gonna wait 1 more minute and see if any more responses come out. But we'll reveal the answer in just a little bit. And thank y'all for participating. Like, there's no problem, no stress with getting something wrong. That's the whole reason we're learning. Like, there's no way you would have known about this answer because we're all learning together. I don't even know if I would have gotten this right when I was learning this because this is a confusing topic. But I don't see any more answers coming in, so I'm just going to go ahead and reveal it. The answer, I see one more. Aif says hybrid. Okay, good. So the answer is multi-cloud. So most companies use multi-cloud just because they can use different features. Yeah, honestly, I hope they have the voting features too. Like, I make like these default polls and I feel like they're not great, but that's fine. Yeah, a poll would be 10 out of 10, but that's okay. We make our own polls here at MLH. Yeah, the answer is multi-cloud. Most companies like using more than one provider. It could also be hybrid. Like, a lot of companies use hybrid a lot, and that reason is because so I guess like multi-cloud is technically the right answer. I think it's like 76% of companies or something use multi-cloud. But then there's like a really close number with hybrid too. And the reason why those are the most popular is because hybrid cloud lets companies keep sensitive data and really important workloads like on private infrastructure, but then they can also use public clouds and use the scale of public clouds so that they can use that for less sensitive data and be able to like leverage both of those. With multi-cloud, though, it's really cool because companies can use multiple public cloud providers, like we were talking about, like Google Cloud Platform, Amazon Web Services, and Azure, and they can do that like at the same time so that they can like improve reliability, maybe like optimize costs by picking certain models for certain problems, and also just like avoid being locked into like one specific vendor because that can create like business problems sometimes too. So great job, y'all. Thank you for that interaction. That was great. Y'all are doing amazing. Powering through this 2-hour stream. You got this. So in terms of like, actually, let's move on to the next section. We'll be talking about core cloud infrastructure. Yeah, piece of fraud. Multi-cloud in terms of biz logic and long-term vision enables firms to avoid vendor locking. Yeah, exactly. You got it. Vendor locking is just like being locked into one vendor, and that's not ideal because then companies are kind of like forced to go with one vendor, and it would definitely be better if they were able to just like pick between two different ones. So yeah, you got it on the dot, on the nose there. So in terms of infrastructure, lots of different infrastructure with cloud computing because it's kind of something like above us, like kind of something we can't really see. So let's talk about like first, like something, the most concrete part of cloud computing, which is the most physical part of the cloud, which is the data centers. So when you use Google Cloud or other services, your data might be stored in a data center in like Iowa, Belgium, Singapore, like I was mentioning, like a bunch of random places. And these data center buildings are giant, very, very, very secure buildings that are filled with like bunch of servers. And within these buildings, it's like loud, it's cold, and there's so much security because this is what's running everything. Yeah. Do they have undersea servers? I feel like I've heard that, but I also feel like that might be placebo. Oh my god, there are. Microsoft has underwater data centers. That's crazy. How does the water just not flood? What? That's crazy. In China. Interesting. Is that sustainable? It feels like that would harm the environment somehow. But interesting. Thank you for that insight. But yeah, apparently the servers are not just dark and cold, sometimes they're wet. And every server inside a Google Cloud data center or something similar is basically just a really powerful computer. Like I think server is kind of like a really like scary word. It's like, what is a server? But it's basically just a gigantic computer. And it's not just like any different from your computer. It's just like your computer on steroids, basically, because they are connected. Like these different computers are connected with like super fast fiber optic networks. So that way you can have data that travels between these computers like so quickly, like probably like speed of light quick, like very, very quick. And the cloud computing itself actually happens when Google connects these data centers like across the world. So I mentioned like Iowa, Belgium, Singapore. So when Google connects these different data centers across the world, it's really powerful because if one of these centers goes down, the other data centers can just pick up that slack like almost instantaneously, which is why Google Cloud can have an uptime, which is like when the servers are available, of 99.99% or higher. So this is kind of similar to like if y'all use hand sanitizer or soap, which I'm really hoping that you do, at least use one. But usually it'll say like kills 99.99% of bacteria. And it's like they can kill all bacteria, but they just don't want to be sued. And it's the same thing with Google Cloud. Like they can probably provide it most of the time because even if like all of their servers go down, at least one will still exist. And that one can pick up the slack for the rest of the servers. So similar thing. It's going to be running like majority of the time. Yeah. And if you wanted to take a tour of the Google Cloud data center, that would be something like really cool, I feel like. But they don't just let like anyone in. There's like really big security concerns with like the data centers and like very difficult procedures to get in, which I mean kind of makes sense because it's like what basically the world is running on. And if like a hacker was to take over, not y'all, like an actual like um, ethically immoral hacker was to take over and take over the data centers, that would be really bad, which is why they have super strong and super secure security procedures. So I guess the other thing that I wanted to clarify is like I told you there's like racks and racks of endless servers that you've got. Google Cloud doesn't just give you like a whole server to yourself. Then they would have to build like millions and millions of servers which they don't have the capabilities for. Instead, they use a process that's kind of called virtualization. So with virtualization, you can split the workload and give each person their own like section of the server without touching other people's sections. So without virtualization, each person would have to have their own server, which would suck because that would be like so expensive, and like Google would have a hard time because like they don't have the resources to build that many servers. And so that's why virtualization is super nice, because that way you can split these servers and maintain the privacy that like people value so much. And then there's kind of this program, it's called a hypervisor, and that's what helps us go through visualization or virtualization. So our hypervisor is something that sits between, like physically sits between the physical hardware, which is like the hardware of the server, and the virtual machines. And this hypervisor like divides the resources. So it's like, sorry, I lied. The hypervisor is not like a physical thing. It's kind of like a virtual thing. And it divides up different resources within the server, like the CPU, memory, and storage. So when you're making a virtual machine within Google Cloud, you're actually getting a small piece of this big server, and other people are using other pieces of that server. Um, type 1 and type 2 hypervisors. Yeah, these are further concepts that y'all can study if you're interested. I'm covering just like basic concepts to make sure that we can get through all the concepts, but also have enough time for y'all to do like demos. But yeah, that's some other stuff that you can go to, different types of hypervisors and what the different hypervisors can do. So it looks like Skidinger's got some good cloud computing knowledge. So I talked about those virtual machines. Once you have those virtual machines, they're going to need to talk to each other and also just like the outside world. And you can think like I'm using Google Cloud for most of these examples, but that's just because I'm familiar with Google Cloud. You can extend this knowledge, extend this like thinking to other public cloud services as well. I'm just using Google Cloud, so like don't like I hope you're not confused about like why I'm using it. But Google Cloud Networking kind of works like you think about it like a map of a city, like whatever cities y'all live in, like maybe a map of like New York, for example. I feel like everybody knows New York. You can think about VPCs or virtual private clouds, like the neighborhoods in New York, like different clusters of houses within New York. Then you have subnets, and subnets are like streets within the neighborhoods. So they take you to different places and they connect the neighborhood together. Then you've got load balancers, and load balancers are like traffic controllers. So maybe stop signs, stop lights, maybe a person physically standing at the intersection to control the flow of traffic. And those load balancers basically just make sure that none of these connections get jammed by a bunch of different people trying to overload it. Just like each house in a neighborhood has an address, each resource that is going in between these different places gets an IP address so that traffic knows where to go. So y'all might have heard like IP address. I'm sure you've heard IP address before. And that's kind of like the address for where the traffic should go. So we're gonna be doing a demo in a little bit, and in that demo, we're gonna like fake create a virtual machine. Obviously, we're not gonna do it like for real because that would require like a Google Cloud license, and I'm not sure that a lot of you have that, and it takes like just a little bit. Plus, you might have to register for a free trial, and again, I don't want to be responsible if you forget to cancel that and it charges you, because none of this is supposed to cost money, and it doesn't. We can just run it like for free as like a simulation demo, and we're going to give our virtual machine a fake IP address so you can see how it works. Like we'll be able to visualize how it works, but not actually like genuinely see how it works, because for that you would need an account, and again, don't want to do that. So yeah, that's like kind of what we're going to do for our demo. And then we've also got cloud storage. So I've been talking about like cloud computing a lot. And there's also cloud storage. So with cloud computing, you have to store different files and different pieces of information. And there's three main types of cloud storage. The first is block storage. And with block storage, you have a virtual hard drive for your virtual machine. virtual hard drive, virtual machine. And with object storage, you use object storage when you have super big files like videos or images. Then you have file storage, and file storage is basically just a shared network drive. So Google Cloud and other web services, other public cloud providers offer all of these, but today we are going to simulate just like the most basic cloud storage, which is just attaching storage to a virtual machine, so that block storage. So we're going to be doing a demo right now, and we're going to simulate what happens when you create a virtual machine within Google Cloud. So normally you would log in to the Google Cloud Platform console or use the Google Cloud command line interface, and you might run something like G-Cloud compute instances create, something like that, like a command to create a new instance of your virtual machine. But again, since we're keeping this beginner friendly and credit card free, we're going to fake this process locally. And if you're coding along, I would open up a terminal or Google Colab, and we're going to code together. So let me get that out for y'all. If you don't have VS Code, feel free to use Google Colab. I would strongly recommend Google Colab just because it's a little bit easier and you don't have to download certain things just for this stream. I'm usually a big proponent of VS Code, but I've been doing like a lot of like really short like fake demos recently on these streams, and I think Google Cloud is better suited for that. Does an IP address same for like everyone? Yeah, so IP addresses are unique per person. They're not the same. Actually, oh, that's a bad idea. Hopefully that was not your IP address. I should not have put in that comment. IP addresses are different for everybody. In fact, like if you watch like YouTube and like popular media, people would be like, oh, leaking this person's IP address. And like it is very important to keep your IP address safely guarded because your IP address is what links web traffic to you. So if somebody knows your IP address, it is not that difficult to be able to get your actual address. So hopefully that was not your IP address. And if it was, no, it wasn't. So we're going to switch over into Google Colab now. So let me show y'all what I'm going to do. Yeah, leaking your IP. I'm actually really sorry, Hamid. I need to start, like, sometimes I just pin the comments and then I read them, but I think I need to start reading them and then pinning them. Yeah, don't leak your IP address. Really bad idea. Someone the other day on one of our streams. Okay, thank God. Okay, good. Yeah, some IP addresses are similar because they might be coming from like similar locations, but never share your IP address. Sometimes, like on your computer, when you're in VS Code, it will link to your IP address. And sometimes, like I've seen people try to debug their code and they'll put it straight into ChatGPT, like with their IP address. And I think that's a horrible idea because, like, even if ChatGPT like might have your IP address in some other way of gathering data, it's never a good idea to just directly copy paste your IP address into like a large language model that literally collects information from you to learn about you. So be careful about where you put your IP address. That's all I'm going to say. Do not post it anywhere publicly, and don't expose it anywhere. But yeah, sometimes they are similar. So we're going to switch over into Google Colab. Let me show y'all what I'm doing. So I went to that link that I just showed y'all. And here is Google Colab, Google Collaboratory. I love this like background they have. It's so pretty. And I'm going to click new notebook. So I already opened up a new notebook, so I'm not going to do all that. But here's my new notebook, and we're going to code, and we're basically going to like fake a virtual machine, like what I was talking about. So we're going to be coding in Python. If y'all don't know Python, like seriously, no worries. That's what I'm here for. I'm going to help you understand what this code is, and we're going to code it along together. You're not going to have to do anything by yourself. We're just going to code along together. So I'm going to do import time and import random. So these are two different modules that I want to use in my code to make it a little bit better. So I'm going to do those two. Those are import statements. We're just importing different libraries till we get our data. So I'm going to do print, and I'm going to say connecting to Google Cloud. So again, like I was saying, we are totally faking this. This is not actually connecting to Google Cloud, but we're just simulating what would happen if we were to do that. So like this print statement, obviously we're not actually connecting to Google Cloud, but we are picking it to see what would happen. So we're going to connect to Google Cloud, and then I'm going to do time.sleep1. If you're curious about what this is, we can hover over it and see what that is. Let's see. Maybe we can't. Okay, that's time. Time.sleep is basically just a function within Python, within the time library. And what it does is it pauses our program. So it pauses whatever we're running from running for whatever time is in that bracket. So for example, here, we're just pausing it for 1 minute, just so that we have like a fake pause to pretend like we're connecting to Google Cloud. And I know this is like a bit dramatic, but I just wanted y'all to like get the experience of running something in Google Cloud without running the risk of running something in Google Cloud. So here we're gonna be like allocating resources in the data center. And we're gonna do the exact same thing, time.sleep. I don't want that. By the way, this is complete nonsense code. Like this doesn't actually do anything. We're just, like I said, simulating, creating a virtual machine. And now we're going to, oh, looks like an audio van. No, go back. Clear. Okay, so we've done that. And now we're going to make like a fake IP address generator to generate fake IP addresses, because I don't want any of you leaking your IP address. I'm very worried about that now. So we're just going to make a fake one. We're going to do IP, our new variable. We're making a new variable called IP. We're going to do F, double quotes, and we're going to say 34.random.randint. Any integer from 0 to 255, and we did 34 dot to kind of start off our IP address, our random IP address, so that all of us have something starting off with 34. And then we're going to do random.randint, so another random integer 0 to 255, and that's all we need. And we're going to end it with a dot. And we're going to do that again, one more time. So random, yeah. There you go. It's got it for us. We're going to end that with a quote. So it doesn't look happy. What happened? Quote. Okay. So then we're going to print. And we're going to say like, oh, we're like provisioning your virtual machine. And then we're going to do assigned IP is, and then we're going to put in that IP value that we just generated. And then again, we're going to do time sleep 1 to give us that like premise of having our system take a break. Then we're going to do print. Like I said, we're going to be using that attaching storage. So let's say we're attaching 50 gigabytes of storage. Then we're going to do our time.sleep1 again. And this time we're going to print, yay, our VM is ready. You can now SSH into it. And like, oh, this is not real. So feel free to copy as much as you want. Don't copy as much as you want. I just want you all to code along with me so you can get that experience. So now we're just going to run it. So in Google Colab, you can just hit like play and it'll run. But if y'all are running in VS Code or any other IDE, you might have to do like Python. So let me show you. So whatever you called your file, like let me add text and just show you what that looks like. But it's going to be so if you're on a Windows, it's going to be Python, whatever name of file .py. So it's just whatever your name of the file is .py. If you're on Linux or Mac, it's going to be Python 3. Don't ask me why. I hate it too. And that's what it's going to look like. So you're going to have to run that command in your terminal if you're not using Google Colab. But since we're using Google Colab, I'm just going to hit play. And look, it's got it. Boom. So, by the way, the time sleep, I lied, it's not 1 minute, it's 1 second. I was like, there's no way it's 1 minute. This is going to be like a 5-minute demo, but it's 1 second. And you can see there. So super nice, super 10 out of 10. It's working. We connected to Google Cloud, allocated the resources, provisioned our virtual machine, and I got an IP address. So there's my IP address, my like fake IP address. And I want y'all to post whatever you got in the chat from this generator into the chat. Don't worry, this is not your actual IP. This is a completely randomly generated IP address. In fact, that's why I did 34 dot in the front. Has nothing related to your IP. So there you go. Donut Guitar got this number. Perfect. So these are all most likely going to be different, but somehow if y'all manage to get the same one, that's going to be crazy luck because these are random number generators and you really shouldn't be getting the same number. But keep them coming. I want to see how many of y'all were able to get this working. Just a quick way to run something cool. And if y'all are having trouble getting that working or need some help, just let me know. Because I kind of only see Donut Guitar replying. So did nobody else get this working? I don't know. I have no way of knowing until y'all send me chat. So I can't see your screen. So is Donut Guitar the cloud computer extreme? Are they the only ones that know how to do it? I don't know. Nobody. Okay. Donut Guitar ran it again. There you go. 34.85.227. Nice. So it's looking like Donut Guitar is our cloud computer extraordinaire for getting this done for us. But yeah, this is just your fake virtual machine IP address. Does anyone else want to try and see what they get? If you're having trouble like with running the code, with getting it to work, just let me know. We can work through it. But ooh, Pizzo Freud. Nice. 34.82. Nice. We've got another cloud computing extraordinaire in the chat here. Hamid too. Nice. Glad to see we're not leaking our actual IP address this time, but nice. Good. So it's working for a lot of y'all. Very good. Even if I move past this section or move past any section, but you have a question in a previous section, just put it in the chat. That's why I'm here. If you have any other questions, then give it to me. Give me your questions so I can answer them. Going Kokomo. Okay, your fake IP is this. Perfect. It's going to be really funny if like anyone watches the stream later and doesn't know the context and they just see a bunch of people typing in their IP addresses, and they're like, oh my god, what is happening? Why is everybody leaking and doxing themselves? But it's not an actual IP address. Only we will know. Skiddigger. Okay. Ooh, I see a different number. It doesn't start with 34. It starts with 53. Nice. Got some customization going on here. Very good. Also desperately praying that none of you are putting in your actual IP addresses because this is public to YouTube, to the world. So desperately hoping none of you are doing that, but you'll know what's up. I know you wouldn't do that. But yeah, okay. So, ooh. Oh, Pizza Freud just copy pasted the entire thing. Nice. Infomaniac. Oh, okay. We changed it instead of Google Cloud. Interesting. Okay, nice. Oh, you've added some other instructions. Cool. Okay. I like it. I like seeing y'all do your own customization and see y'all have your own like tweaks to it, adding your own personality to it. I like that. So I do think that is mainly it. Don't think I see any more. Okay. Good job. Good interaction. Y'all did great. Glad to see it's working for y'all. And now we're going to move on to the next section. So now we're going to be talking about how cloud services are delivered. So we are going to be going into like how you can actually interact with the cloud, and we're going to be doing another serverless simulation demo. Again, without the server because it's too complex to do all that within a 2-hour stream. And we've only got 1 hour left, so we're about to hit that midway point. So good job to y'all for being able to get through 1 hour. You're almost there, 50% through. Power through the rest, and then you'll have some cloud computing knowledge. So on the topic of how cloud services are delivered, when you use Google Cloud, again, using Google Cloud as a general example, you have two main ways that you can interact with it. The first is the Cloud Console. So this is going to be the web dashboard that you're going to log into. So this is like you search up Google Cloud and you have a dashboard. That's your Cloud Console. Super beginner friendly, super easy to use, and it shows you all of your services visually. Then, if you want to use another way to interact with Google Cloud, you can also use the API and CLI, which is the command line interface. I am blurring my words together. This is how developers and scripts are able to talk to the cloud in a program. So if I wanted to start a virtual machine in Google Cloud's platform, I could click different buttons within the console, or I could send like an API request, like a post API request, to get that rolling too. But we're going to keep this super simple, and we're just going to simulate our requests locally. So in the real world, cloud engineers, so people who work on the cloud, are not like manually clicking through the console every time I need something, because like think about how tedious and how much of a hassle that would be if they did that. Instead, they use automation tools to describe infrastructure and code. So this is called like infrastructure as code, using these automation tools. So you're able to give the cloud exactly what you want, and the cloud's able to build this for you. So Google Cloud supports like different tools like Terraform or Deployment Manager for this very process to help you build what you need for your cloud. But those are a little complex to go into in like terms of like how the tool itself works. So we'll just talk about like the concepts of the tool for now instead of going more in depth into like what the tool is. Within Google Cloud, you've also got containers, and containers are containers in the context of clouds is very similar to what containers actually are in real life. So containers are basically these little boxes that are super portable and movable, and they can hold your app and everything that it needs to run. So just like containers in real life, they're lightweight, easy to start with, and like really easy to just grab and drop, move around. So in Google Cloud, Kubernetes, which is via the Google Kubernetes engine, is basically the system that helps you manage a bunch of different containers across multiple different machines. Peter Ford says, Podman, Handshake, Kubernetes. Yeah. If y'all are curious what that is, let me see. Podman is just like helps you run applications too. What is Podman versus Kubernetes? Is there a difference? Podman is apparently more secure than Kubernetes. Yeah, there's a lot of different like cloud container managers like Docker, Podman, Kubernetes. But yeah, they are definitely handshaking each other. They definitely go hand in hand. We're not going to deep dive into like Podman, Kubernetes, or Docker today. But as a general concept, you can kind of think of it like a cloud traffic manager for the containers that your app has. Podman is a drop-in replacement for Docker, but more secure since it's a daemonless tool. Yep, exactly. It is definitely more secure than Kubernetes and Docker. Yeah, good knowledge, Pizza Freud. You've got some good cloud computing knowledge. Glad to see this stream is resonating a little bit with what you know. And I think something really cool about cloud computing is serverless computing. So that name is kind of misleading because there are still servers, you're just not managing them. But with serverless computing, you basically just write your code and then you upload your code. So Google Cloud will automatically be able to run your code when it needs. It scales it up when a bunch of people are using your services. And then again, similarly, it scales your code down when nobody's using it. So just like I was saying before, it's a pay as you go model. You're only paying for the actual time that your code's running. And Google Cloud Functions is what Google Cloud Platform serverless platform is. So that's like Google Cloud Functions is what it's called. And we can simulate a serverless function in another live demo. So in the real Google Cloud platform, you would upload your code to Cloud Functions, and then GCP would run it in response to an event, something like maybe an HTTP request. But we're just going to mimic that locally so you can see what happens, because otherwise it's way too much work for us. So I'm going to go back to Google Colab. Feel free to go back to whatever code editor you were using before. No, I don't want it there. Okay, good. So we're going to go back to our Python file. If you're in Google Colab, you can just add a new code block. You don't have to like open up a new file. So I'm going to do from Flask, import Flask, common request, Flask, common request. So I'm importing another library here to make us an app that looks super cool. App Flask. It's already got something for us, but we are going to do a little bit more. So this is correct. The app route is starting off with that, but we want to do it at hello. And then we're going to start our methods equal get, all caps. And then just like it had before, we're going to do a hello world because this is one of our first projects and we always do hello world. We're going to do name, we're going to set name, and we're going to get these arguments, name and world, and we're going to return hello name, and we're going to say this is simulated serverless function. Yay! And then we're going to go down to our main and we're going to say, we're going to have it print out something for us. Print starting simulated serverless function. Again, like the fake stuff that we're doing because we can't use the real stuff, but similar processes. Instead of just doing app.run, we're going to specify that we want it running on port 8080. Okay, so we're going to take this out and I'm going to open up my terminal. Got my terminal here, and I'm going to do pip install Flask. So y'all can do this in your VS Code, in whatever IDE you're using, and you can see that requirement's already satisfied because this is Google Colab and Google Colab is on top of it. And I'm going to do Python 3. I actually don't know what this file is called. Let me see. I wonder if I can just run it directly because this is Google Colab. Okay. Doesn't look happy with me. I wonder what this file is called. This is the problem with using something that you don't typically use because I don't really use Google Colab. I don't know what this file is called. Okay, maybe we'll switch over to VS Code, going back to my roots, to who I really am. Let me check. Yeah, it looks like Google Colab is not working, but that's okay because we can always switch into another environment. Okay. So we've got this here, got it pasted exactly what I had before, and I'm gonna open up a new terminal, do the same thing, hit install Flask. Okay, and then I'm gonna do Python 3 hi.py. Okay, it's working in VS Code. And then, so if y'all didn't see what I did, this is in VS Code. Hopefully it might be, oh, you didn't see anything. Okay, that's not nice. So I basically just copied and pasted my code into VS Code because Google Colab is giving me some issues. It's probably some like native rule that I don't know about, but you're just going to you're going to go into VS Code, you're going to do pip install Flask, and then you're going to do Python name.py. If you're on a Mac or Linux, it's going to be Python 3 name.file.py. Yeah, so that's what I did, and you can see it's running. So in my Google browser, I'm going to go to this address that it's got up for me here. It's got 8080, and I'm going to hello mark name equals GCP. So this is what we're gonna want to go to. Let me put this in VS Code for y'all. Just so you can see it. This is the address that we're gonna want to go to. It's going to be the same for you just because we specified what port we want our localhost to operate out of. So I'll put that in the chat and highlight it up for y'all. But that's going to be what we want to go to. And you'll see that once we go there, you will be able to see what we had. So let's go to that website. Let me show y'all. And boom, it says, hello GCP, this is a simulated serverless function. There you go. So that was super cool. We just ran our serverless function locally, and we can try changing the name in the URL too. So let's go back to the code. So here, I put name here. So I put hello name, and it'll do GCP there. But what I can do instead is I can try changing that name. So what I can do is I can manually call a name. So I can do like name equals Bob. Bob. And now let's do that again. So open up a new terminal. Python 3 hi.py. There you go. So now I'm going to go back to my URL. You didn't see anything. Sorry, guys. But I basically just changed the name to Bob. And I said, hello, comma Bob. And now I'm going to go back to my URL. And we're going to see something new. Oh, oops. I was not supposed to do that. Never mind. Okay, let's try that. New terminal. Not split terminal. New terminal. Python 3 hi.py. Oh, oops. Okay. does it not look happy with me? Oh, okay. I'm just trolling. Sorry. You can't see your screen. Oh no, I meant to show the VS Code. Don't worry. You are looking at the right thing. So basically what I did was I tried changing that name in the URL. So I added in a second name and I put in second name here into my code. So now I'm going to show you what that looks like on my website. It looks exactly like what you would think. There you go. It says, hello, GCP and Bob. This is a simulated serverless function. Does anyone want to put their name or something similarly appropriate in the chat, and I can change it to that, and we can do some fun little custom greetings. Y'all can also change it locally and make these different greetings. So let's see how creative y'all can get. I'm curious. I'll just take like the first one that comes in so we can keep moving. But name equals jelly donut. Okay, I like that. I like that. I think you really like donuts, man. I support that. I kind of want a donut. I feel like it's been a while since I had one. I had one maybe like 2 weeks ago. I want a donut. Maybe I'll go get a donut after this. Our name is going to switch to jelly donut. Okay. Let's save that. So also something you can do instead of reopening oh my god, yeah. Man, I want a jelly donut. So we're gonna go something that you can do in your VS Code or any other IDE that you're using. You don't have to like delete the terminal and then reopen your terminal. You can do Control-C like it says here, and it'll quit running. And then you can save your file like I'm gonna do here. I'm gonna save it, and then I'm gonna go here and I'm gonna go back and I'm gonna say Python 3 and run my code again. So now it's going that again. I'm gonna go back to my original URL, and it should say jelly donut. Let's see. There you go. Hello, GCP and jelly donut. It does work, so we can just change it to whatever we want. And that's basically our serverless function. Thank you for that interaction, Tony Guitar. And so at the end of this, we've created our own serverless function, and we've seen how cloud services are delivered. Ooh. If you press the upward key in the terminal, it will give you the last command you ran. Let's go try that. That's fun. I like that. I love tips and tricks. I feel like I hear a lot of tips and tricks, and it's always like, I always forget to do that. So let me try. Okay, Control-C, let me command, let me quit. Go back to VS Code. No, it's hiding VS Code for me. Oh, I screwed something up. Now I can't click on VS Code anymore. Come back. Wait, let me try. Let me stop screwing. Can I go back? Okay. Sorry, technical difficulties. Let me add it. There you go. Okay. So I did that. If you do up arrow. Wow, that was cool. Okay. That's cool. That's super cool. Thank you, ZZZ. This is very helpful so that I don't have to keep copying, or not I keep typing them. It's not like that hard, but that's cool. Thank you for that. So like I was saying, we've created our own serverless function. That was super cool. And we saw how cloud services can be delivered. And something super important in relation to like how cloud services work is keeping all of that super secure, because the cloud is super powerful, but the cloud's only going to be as safe as the safety that the people using it take when they use it. So with that, we're going to segue into our next section, which is security and compliance. Ooh, can you tell us more about Kubernetes? Yeah, for sure. I feel like Kubernetes is definitely something that like is used a lot. Not used a lot, like is talked about a lot. But basically Kubernetes is like what I was talking about earlier. It's an open source like container manager. And all it does is it makes it really easy to deploy software, to scale software, and to manage software. So Kubernetes was originally designed, I think it was by Google, and now it's not like mainly maintained by Google. It is maintained by like a bunch of community members, hence like open source. And basically, what it does is it takes one or more computers, so either like actual computers or virtual machines, and it kind of forces them into a cluster, and they can work a bunch of different workloads within containers. I guess just like how it works. It's a specific type of container manager system where it creates different like groups of containers and they deploy together. They share this network space and the name and the IP address. So it's really helpful when you manage containers because they're able to be grouped together and they are able to like communicate with each other and be exposed, like deployed together. Yeah, a little bit of like an intro to Kubernetes. In terms of like a deep dive, there's definitely a lot of things that can be covered with Kubernetes. Let me think if there's like anything else that's interesting. But mm, yeah, it basically just manages containers in a bunch of different ways so that like the human doesn't have to do it manually, and so that it can be done like automated. Hopefully that makes sense. Uh, Let me know if it doesn't, and we can talk about it some more. But like I was talking about, security in the cloud is super duper important. Yeah, let me know if you need any more help. Um, So, for beginners, security in the cloud is really important. Like security, we kind of think about it as like a physical thing. It is something that we see like that can physically protect us, but security in the cloud is obviously digital. So, for y'all, like as beginners, the most important thing that you have to know is that platforms like different cloud providers, like especially public cloud providers, will handle a lot of this heavy lifting in terms of security. Like they'll have a lot of physical data center security. So I was talking about those big data centers, like even the underseas ones, they have really big security, really like impenetrable security. They're very hard to get through, and they keep their systems updated so that there aren't that many security risks. But you still have a lot of responsibility for security because you set up your account, your permissions, and your data, and you have to make sure that all of those are secure. So, one of the most important concepts in terms of security within cloud computing is something called the shared responsibility model. And that is basically meaning that security is split between the cloud provider and you. So, with Google Cloud Provider, they've got their own job. They keep their hardware, network, and core systems secure. But you also have your own job in maintaining the security of the cloud system, and that is making sure that your data, user permissions, and configurations are all secure. So if you give everyone admin access, for example, like on your own end, that's on you. Even if GCP is like super good and they are like doing everything properly, correctly, if you give everybody admin access, like there's no coming back from that. So it's really important to be careful with what you're doing and make sure that you're maintaining security within Google Cloud. So, a little bit about what basic security practices in GCP are so that you just know you have context around that. You can use identity and access management. So maybe you've heard about that, but that's basically just making sure that you are giving everybody like the minimum amount of permissions they need. I know that might sound a little counterintuitive because it's like, wouldn't you want to give everybody like maximum permissions so that they can like use whatever they wanted to? But no, we want to give everybody minimum permissions so that they don't use things beyond what they're allowed to use. You might have also heard of like two-factor authentication. You also want to do that so that you can add like a second layer of security. That might be look something like an authentication app. Like some people use like Duo, like some universities use Duo. And similar things like that. It's really important to make sure that you have two-factor authentication because like pretty useful. And you also might want to encrypt your data. GCP usually encrypts your data like by default, but you can add extra layers of security that will help you too. So we can also like set up IAM roles like by ourselves. It's super lightweight, doesn't really require expensive services. You would just go into like your Google Cloud Project Console. You'd create a new project and maybe you'd call it like security demo or something related to that. And then you would go to the identity and access management section and you'd go into that, you go into admin there, and you would like maybe add a test email, for example, and you would assign a specific role that would be like viewer or commenter instead of owner. And you might have seen that sometimes in like Google Sheets or Google Docs. It's really important that you're not giving too much access to people, which is why you do like viewer instead of owner, because all they really need to do is view. They don't really need to own. And that is a really easy way that you can control access. So instead of giving somebody like access to everything, you're just giving them access to part of it. And you can kind of think about it like maybe like an example. Like there's a lot of startups these days, and I feel like startups have a lot of difficulty with safety because their main priority is like thinking about what they can do and how they can maximize profit, and that usually comes at the expense of security. So let's think about a startup maybe that stores like customer orders, including like customer order details in the cloud. So each startup usually has like, or each company has developers who are helping build out the product. They're like developing the product. And typically, let's say the startup gives developers owner access because it's just easier. Like you don't have to add them to things and you can just help them out with different things. So if like, let's say, since the developer has owner access, they can delete a lot of things. Let's say accidentally they delete the entire database, then like your whole database is gone. There's nothing you can do. It's just gone permanently. So that's why it's really important to make sure you're prioritizing identity and access management or IAM because you want to have editor access only and viewer for everybody else. Because otherwise they'll be have like developers will have access to things that you don't want them to have access to. So just like key takeaway, make sure that when you're giving access to people, you're only giving what access is needed and nothing more, because otherwise you will run into catastrophic errors that you don't want to have. And yeah, Peter Freud and summary. Yeah, so this is a little bit more in-depth answer to your question. Containerization software like Podman lets us containerize our apps and services for scaling. We can then use Kubernetes, which is a software to manage containers. Yeah, so you can use Podman to first make your apps and services into containers, and then like I was saying, Kubernetes is kind of like your container manager. Yeah, Kubernetes orchestrates orchestrates containers. Orchestrates, manages, similar concepts. Yeah. But like I was saying, GCP has a lot of security tools. They've got like the security command center within the free tier actually, which is really nice. Like GCP has a free tier and like a slight premium tier. Like they have different pricing tiers. But if that ever interests you, like you want to use GCP, they do have a free tier to try things out on. So that free tier will be able to give you like a list of like risks and recommendations for your project so you can see what is important. And it also does give you something that I think is super cool, gives you like cloud audit logs. So if you've ever used AI or like any type of program, you'll see that a lot of things have audit logs. And that's just like a record of things that you can like see happening. And with cloud audit logs, like you can still see like what happens, who did what, when they did it, and things like that. Yeah, we're not going to go too deep into like the different security configurations, but just like it's a good idea to know that they exist so that you know that these like really important pieces of technology aren't just like random. They're held in security. So I'm curious. So, do you think you should give owner access to someone within Google Cloud Platform if they need to upload files? So, your options are A, A, yes, B, no, C, doesn't matter. And again, the question was just like, if you give somebody owner access within Google Cloud Platform, or if someone's just uploading files, do they need owner access in Google Platform? I don't know. Is it yes, no, or does it matter? Do they need that owner access to upload the files? Is it necessary? Is it not necessary? Let me know what you think. Yeah, in AWS, using Secret Manager is a paid service, not covered in the free tier, but we use AWS. Yeah, in Google Cloud Platform, it is free, but yeah, like in AWS, Secret Managers is paid. So there's other ways to get around it, though, like Pizza Freud mentioned. Okay, no, 9. Gamer Tabby says no. Pizza Freud says no. Pizza Freud is very strong in their no. They're switching to German there. Donut Guitar says no. B. Perfect. Okay. Anybody else have any other opinions on what we think? If somebody's just trying to upload files, do they need owner access? Do they not? I don't know. What does everybody else think? Okay. I don't see that many more answers coming in, so I'll just go ahead and spoil it. Ooh, can't I just take the files and upload them myself? You could, but think about like scalability. If there's like thousands of files, it would be such a hassle for you to take them all and upload them by yourself. It would just be easier to get this other person to upload them. So yeah, that's definitely an option, but it's just so much extra work for you. That's why you've got employees, you know what I mean? B for Boston donut. Oh, don't the Boston donuts have like Boston cream in them? Boston donuts. What is a Boston donut? What is a Boston donut? Ooh, round chocolate frosting, custard filling. Oh my god, that sounds really good. Damn it, donut guitar. You got me in the mood for donuts. There's no donuts near me either. Damn. But y'all, oh, no one is saying C, so C. Okay. Owner access just seems too much, and I don't. Yeah, valid. So the answer is B. Everybody is correct. Skidinger, I think, just wanted to be different. Valid, but I know you know that the answer was B. Yeah, if you want to give somebody, if you want to upload files, they don't need owner access. You only need owner access to like own something, change something. You're just uploading files. You can have editor access. Again, we don't want that example that I was using before where like the startup has a developer that just deletes the entire database. You want to make sure you're separating access to different parts of the company. So yeah, B is correct there. Good job, y'all. You got it. So I guess like key takeaways from this like security section is just that like beginner cloud security isn't like making sure that you're hack proof to different things. Like you don't really need to know about all that for beginners. It's just more about like you have to know about shared responsibility, that you share responsibility with Google Cloud Platform. Both of you work together to make sure that your system is secure. Give minimal permissions, don't give owner access or editor access to people that don't need it. Use two-factor authentication. Yeah, that like those couple of tips will cover the majority of mistakes that you might make as a beginner. So just a good little dive there. And we can also I think I do. Yeah, okay. So we can also think about cloud computing. Like we've been doing theory so far, but we can also think about cloud computing like in action. So you like using Google Cloud Platform. So basically, we're going to use the cloud to host a website, which is one of the most common uses of clouds is like to host the website. And we're going to be using Google Cloud's storage to host a static HTML website. If you don't know the difference between static and dynamic, static just stays the same, doesn't update based on data, and it looks the same for everybody. Dynamic changes based on who is looking at the page and where they're looking at the page. This is going to be perfect for y'all because we don't have any servers. We don't have any really difficult to understand networking either. So we're just going to create a simple HTML file, upload it to a Google Cloud GCP storage bucket, and make it public. So if you don't have GCP set up, no worries. We can run it locally on our browser too. It's chill either way. So basically what we're going to do, I'll show you both. So I'll first show you the local way so that all of y'all can do it. And then if you want to run the Google Cloud way, we can also do that. So I'm going to go back to my VS Code. I think in practical, this owner will use root account user and will create respective users for the stakeholders. Yeah. This is more like, this is definitely more of what will happen in the real world. Like the owner will have primary owner access, like root account user, and they'll create different users for different job roles. Like you've said, like developer, business analyst, whatever. That is usually what happens, just like kind of a dumbed down version of like owner, editor, viewer. But yeah, typically in companies, they have way more advanced roles because owner, editor, and viewer is not enough to encompass like the complexities behind what roles different people may hold. So you got it right there. So we're going to go back to VS Code. Let me go back and start sharing VS Code. Okay. We're back to VS Code. We're going to open up a new file, and I'm going to call this my HTML file. So I'm going to call it gcp.html. Feel free to call it whatever you would like. So if you haven't coded in HTML before, the first line is always this like exclamation point doc type HTML, just declaring it to the file that we are going to be coding in HTML. And then we're going to have these little arrows at the beginning and end of each of our like pieces of content, because that's how HTML works. We've got our arrows, they're called tags. Oh, I can't remember. Somebody was calling them something else yesterday. Tag, it was something else. I don't remember what it was, but it was like by the way, it's also called this. And I was like, damn, I didn't know that. And I was like, oh, I'll use it in the future. And I totally just forgot it. So that's on me. Maybe I'll go back and watch my YouTube stream and try to see what that person was saying. And if you'll notice, it also auto creates another one of these with this slash in front of it. That's because that's a closing tag. So that indicates that we are done with that specific type of HTML input. So here we've got title. We're going to make our title, which is basically what will be on the top of our browser. And that's what I'm going to put. I'm going to put hello cloud instead of hello world because we are talking about cloud computing today. So I got my body, and I'm going to do an H1 tag, which is basically just heading. I'm going to say welcome to our cloud demo. Yay! And then I'm going to do a P for paragraph tag. Wow, I'm really going through it. Hello? Okay. This page is hosted on Google Cloud Storage. Okay, so. There it is. ZZZ. Ankle bracelets. I think you were the one that said it yesterday too. Yeah. Apparently these things can also be referred to as ankle bracelets instead of just tags, which I think is super cool. Yeah, that's pretty cool. Ankle bracelets, fun. So going back to our code, yeah, we got my body and we got our HTML. Perfect. So we're going to pretend like we don't have a GCP account. I'm going to open up a new terminal, and I'm going to do Python 3 here because, again, I'm on a Mac, but if y'all are on Windows, I would just run Python, HTTP server, and I'm going to run it on port 8080 again. So it says it's running. So let's open it up. So you are going to go to this URL, http://localhost 8080. I will copy that paste and give it to y'all. It's going to be the same because I specified what port I wanted it to run in the terminal. There you go. Mm-hmm. Oh, hold on. I actually need to make a new folder. It is confused. Mm-mm-mm. Yeah, because I just tried to copy it. I don't want to save changes. But I need to make a new file. Y'all probably don't have to do this, but maybe you do if it's not working as it should. Do gcp.html, make that, paste it. I'm gonna save it, open up my new terminal. I'm gonna do my thing. Should I do the up arrow? Oh my god, I can. I love whoever told me that. Nice. Okay, so that works. Let me show y'all what that looks like. There you go. So in our tab, not sure if you can see the tab from here, but it says hello cloud. So it's got our welcome to our cloud demo. This page is hosted on Google Cloud Storage. Obviously it's not. Let me actually show y'all like what the tab looks like. Sorry, it's gonna be an infinity screen for a second. You can see that actual tab. It says hello cloud, and that's what that heading is supposed to be. Yeah, hopefully that worked for y'all. Let me know if it didn't. Let me know if you need help. Yeah. So now we're going to try and actually install the Google Cloud command line interface. So if you don't want to set up Google Cloud GCP on your computer, like that's totally fine. But I'm going to do it just because I think it's fun. So I'm going to do it with y'all. And we're going to download the G Cloud CLI. Let me get that link for you. It's going to be at this link. So follow these installation instructions. I am just going to download it. I don't know what version. Settings, system, about, system. Sorry guys, I'm trying to find out which version of Mac I am. Device specifications, system type. I did this before and I just don't remember anymore. Okay. Let me go back. And we're going to run this file in VS Code. Oh. Damn. Hold on. I think that's supposed to be running my terminal. Actually, I think I'm lying. Oh my god, this is so difficult. let me try reading that. Damn. It's not running. Let me see. Oh, okay. Sorry, let me show you what I'm seeing. So I went through my command. I put in this command, Google skk install. I said I do not want them to, I don't want to improve their stuff. It has all this. I said modify profile, sure. Sorry guys, I don't really know what I'm doing. This is like, I'm doing this live with you. Hopefully this works. Yeah, it's installing it. And then initialize Google Cloud CLI. Okay. Okay. It is done. So now I'm going to initialize it. You must sign in to continue. Okay. It'll just open you up to a new like Google login page. So hopefully you'll have a Google Cloud login. Yeah, I signed in. GCP stream. Okay, good. It is running. Sorry, I know that was a bit complicated, complicated, but if you just follow the installation instructions on the website, it works perfectly. You just got to go through all of it, and then at the last one, you have to run gcloud init using that, and then you're done. So if you're following along, I'm going to go ahead and continue working in the terminal commands. So I'm going to add some terminal commands. I'm going to create a bucket. So I'm going to do gcloud storage buckets. I'm going to create GHW stream bucket. Oh, bucket. I'm going to do dash location equals US because I'm within the US. Damn. Command not found gcloud. Why? I did install it. Okay, I think I'm supposed to be bash, main bash. I'm in CSH. Okay, let's switch over. Oh. Oh, wait, never mind. Bruh. Okay, so it's not working in bash either. I think you need to add it to your path to be recognized. See, man, I did add it to my path. That's what I had this little question up here for. It asked me up here. Yeah, modify profile to update your path and enable. And I said yes. So it just hates me. That's fine. Well, let's see if it runs gcloud in general. Gcloud -- help. Aha! So it doesn't work at all. Okay, so I am in the wrong path. So what path did it get? Mm-mm-mm. Maybe check if it did add to your path. Yeah, let me go through and check that right now. Mm-mm-mm. Start a new shell. Okay. Oh, nope. Nope. Okay, that's fine. Ah! Bruh. Aha! Damn it. Okay. Oh, that's fine. Okay. Okay, so I figured out the problem. I did not read the instructions like I should have. But when it was installing, it said that you have to open up a new shell after you've installed. So if you're getting the same error, just click new and open up a new ZHS terminal shell, and it'll work for you. So let's fix that. So we're going to do gcloud storage, buckets, create. Oh, I spelled create wrong. Bruh. Mm-mm-mm. Okay, sure. Okay, I'm gonna stop here because it looks like I don't know what I'm doing and I haven't really worked with the Google Cloud command line interface before. So we have some more content to cover anyways, but we saw how that works locally, like without a GCP account. But yeah, this is a little bit about that. I'm just going to skip past that part now because I don't think that that's gonna work in time since we've only got like 16 minutes left. And I don't want to permanently mess up my computer because I think I already did. It is starting to buffer. I'm going to take a small break from that. Take a step back from working on that. I see a comment. Mm-mm. Can you explain how K8's optimization and FinOps work? No, it's not really your stuff, but I just want a simple understanding. Yeah, for sure. I'm honestly like not that well versed in this either. I just like studied up enough for this like beginner stream. But I know that cost optimization is like it's really good at cost optimization because it reduces the cost of running these applications, and it like efficiently uses different resources like CPU, memory, and storage, so that you don't have to over provision, which would lead to unnecessary costs. And there also are like specific tools to optimize like massive like different pods or clusters that Kubernetes does. Some people use like open source tools because Kubernetes itself is open source. People will use like KRR, or like Kubernetes like autoscalers, like built-in tools as well. So that's a little bit how the optimization works. They've got a lot of built-in tools there. FinOps. A new approach to essential aspects of managing and scaling Kubernetes clusters. Okay. Yeah, I honestly don't know too much about this. Goal is to maximize revenue or business values. I'm guessing like financial operations, cost savings. Yeah, I would definitely suggest like reading up on this if you're more interested in this later, just so we don't like derail the stream. But there's a lot of really good resources that I'll go over in the end too, to help you enhance your understanding of optimization and how Kubernetes works in general. So I will help you and share those resources in just a little bit when we're almost done. Yeah, so hopefully y'all are able to see like how useful cloud computing is, like being able to store all of this locally, and we can like have starter files like HTML files like we just saw, and we can run it locally on our computer. But if we have GCP access and are able to use that like Google Cloud Project command line interface, then we can upload it to cloud storage and store it there. And that's super cool. So we can like get our page live, and run it like via Google Cloud, which is super cool. You don't have to like store it locally, store it in the cloud. And yeah, so kind of like moving on, that was like our little mini demo there. And looking ahead to like what cloud computing is. So I'm sure y'all have heard about artificial intelligence and machine learning a lot. Some of y'all went to my stream yesterday. You might have heard like me talking about machine learning a lot. Like we are kind of entering this era where we're able to use artificial intelligence and machine learning itself as a service, which is super cool, because cloud providers are making really, really powerful AI tools, and they're making them available to everyone without huge infrastructure. Like think about ChatGPT, like you can use it without huge infrastructure. But that imagine that with like the power of cloud computing, so that you could use like voice recognition or image analysis to any apps that you're building with just like a couple lines of code like we were doing in our demos. And you can also think about it like having serverless everywhere. That's kind of what a lot of people see happening in the future for cloud computing. We are moving towards like writing code that just runs when it's needed, as opposed to having like different servers to manage. So that way we can make development really fast and really cost efficient too. So like Crane Deck, going back to your FinOps there. And also, we are going more towards hybrid and multi-cloud. Kind of going back to that question I asked y'all at the beginning. Companies want a lot of flexibility and they want to be really reliable for other people. So it's really important for them to like spread different workloads across multiple clouds, hence the multi-cloud, and also being able to combine like private and public clouds so that they can enhance their cost optimization. Because like for a lot of companies, decreasing costs and making sure you're optimizing for your current costs is really, really important. So that's definitely another reason why you want to have hybrid and multi-cloud as well. So there's a lot of different career paths and just in general skills too that you can do in cloud computing. Like if you're generous or not generous, if you're curious about what a future in cloud computing could look like. So like to get there, you'd probably have to like go through learning the clouds and basics, for like Google Cloud, Amazon, web resources, things like that. Lots of different resources that you can take up there. And we've also got like different certifications. There's like, maybe it's just like Google Associate Cloud Engineer or something like that. It's very cool. Good certifications that you can do to certify yourself within cloud computing. Lots of different like methods and different things that you can use there. There's also like different roles within cloud computing. I feel like cloud computing is not talked about as much within like the software engineering space. And there's a lot of different roles like cloud support engineer and things like that too. And yeah, Cloud Native Computing Foundation. There you go. Your community members helping you out there. That's a good resource. And yeah, for AWS, AWS Skill Builders helps. You could choose your role for what you would like to explore in the future within cloud computing. So the cloud is powering a lot of the technology around us, and it's in really high demand. So I wanted to end a little bit earlier so Quinn has some time to get on the stream before the Global Hack Week stream. So that's the end of our stream. If y'all have any questions, please feel free to ask them. While I still have you here before y'all start logging off, please fill out this feedback form whenever you get the chance. Ideally like right after this stream, just so that we know and we have your feedback. If you like this stream, if you didn't like this stream, if there's something you would change about it, please put it in the feedback form so that I can use this to improve on my future streams and to get some feedback from y'all. Also, if you have any feedback in general about Global Hack Week, fill it out at that link too, just so that we can make this better for y'all, because we do all of this just for you. And hopefully you're enjoying it so far. Cheers! Yay! What am I doing? What am I doing? Oh my god. So yeah, that's the end of our stream. I will stick around for a little bit if y'all have any questions. But if you're curious about what's up next, so this was the last stream for day 4. We are going to be starting day 5 now, and Quinn is going to kick us off with day 5 at this link. We are going to be going over today in Global Hack Week day 5. So thank you for joining the last stream of day 4, and feel free to head over and join the first stream of day 5. Yes, thank you so much, Donut Guitar, for your engagement and for paying attention, listening in. I'm going to stick around for questions for like maybe 5 more minutes, and give Quinn some time if he needs to get into the stream session earlier. But I'll stick around for some questions. Thank you all so much for joining in. And I'll play some music and wait for some questions to come in so we're not just awkwardly staring at each other. Yeah, for this one, yeah, building emulators is not legal. Resources that you can use to learn about virtualization. There's lots online. I would start out with like Amazon Web Services, Azure, Google Cloud Platform, like certifications there. That can definitely help you. There's also some good resources on like Red Hat to help you learn about virtualization. There's like so many good resources to learn about that. If you want more hands-on practice, I'm sure if you go through those courses, they also have some good examples for that too. But yeah, don't be building emulators. Pizza Freud's got some resources for you. Skiddinger, make sure you check that out. Thank you, Pizza Freud. Pizza Freud. Yeah, open source courses are free. That's great. Yeah, there you go. Pizza Droid. Bye. Have a good day. Yeah, feel free to log off whenever y'all are good. If you don't have any questions, I'm gonna log off in like 1 more minute. Okay, doesn't look like I have any questions. I'm gonna head out, but if anyone else has any more questions that come up now or later, just text it in the Beginner Speak channel and I'll be checking that. So thank you all so much for taking the time to come to my stream. Have a good day. Bye.